Okay, so we have one section left to do in chapter 7, and it's kind of a doozy. So
we can do it.
We kind of put it off, and now it's time. But I want to keep it in context to everything else that we have done in chapter 7, or almost everything else. So let's go back and look at some of the problems that we did. And then we'll look at what we're doing today. Because I want you to be able to differentiate between what's happening today and what happened then. So the first kind of problem we had in this chapter was simplify. So let's say we wanted to simplify x squared minus 4 over 2x plus 4. And simplify simply meant to cancel. But do you remember this phrase? You can only cancel factors. So we had to factor first and then cancel. So on this problem, x squared minus 4 will factor as the difference of squares. X minus 2x plus 2. With 2x plus 4, I could factor a 2 out. So I'd have 2 times x plus 2. And now, because things are being multiplied, now I can cancel. So x plus 2 will cancel with x plus 2, and we end up with x minus 2 all over 2. So a simplify problem is a cancel problem. I'm going to put cancel that here. Okay. The next kind of problems that we had were multiplication and division problems. I'm going to do a division problems, and the directions for these would say perform the indicated operation. Oops, off the screen. So maybe we could do a problem like this. 3x plus 9 over 5x plus 25 divided by x squared minus 9 over x squared minus 25. So this is a division problem, and we know that when we divide fractions, or in this case rational expressions, we multiply by the reciprocal of the second. So we're going to have 3x plus 9 over 5x plus 25 times x squared minus 25 over x squared minus 9. Now it's a multiply problem, and let me ask you guys again, is a multiply problem a cancel problem or a common denominator problem?
Cancel.
It's a cancel problem, but you can only cancel factors. So let's go through and factor. Out of 3x plus 9, we could take out a 3. Just going to leave x plus 3. Maybe I should have done that in red to show a different step of the problem here. Differentiate it between what's up above there. There we go. And out of 5x plus 25, I could take out a 5. And that'll leave x plus 5. What do you guys want me to do when I factor x squared minus 25?
X plus 5, x minus 5.
Okay, the difference of 2 squares. And somebody not named Grayson, tell me how to factor x squared minus 9. X plus 3, x minus 3. Okay, now let's cancel. Well, there's not that much that's going to cancel here, but we can cancel x plus 3 with x plus 3. By the way, do you guys see this boo-boo down here? Did you guys catch that boo-boo? That should just be an x plus 5 there. Sorry about that. And now that x plus 5 will cancel that x plus 5. And so we're going to end up with, in the numerator, a 3 and an x minus 5. And in the denominator, a 5 and an x minus 3. So what's the moral of the story? A division problem turns into a multiplication problem, and a multiplication problem is a cancel problem. So simplify means to cancel, and multiply means to cancel. Sir. So the next kind of problem that I'm going to put up would have the same directions as the one that I just gave you. Let's see the difference. Let's say we had 5 over x squared plus 7x plus 10 plus 3 over x squared plus 8x plus 15. Which is an add problem. So is an add problem a cancel problem or a common denominator problem? Are you okay? It's common denominator. Okay, so really, to this point in the chapter, we've had two kinds of problems. We've had cancel, that always means factor first, and we've had common denominator. That's it. Those are the only two kinds. So today, we're going to do something a little different than both of those, but let's go ahead and do this problem. Before I get common denominators, let's factor the denominators. Two factors of 10 that add up to 7 are 5 and 2. So that factor is x plus 5, x plus 2. And on the second one, two factors of 15 that add up to 8 are 5 and 3. And my goal is to get the denominators the same. So that means on this denominator on the left, I need a factor of x plus 3, which means I got to multiply in the numerator as well by x plus 3. What about over here on the right, class? X plus 2, which means I got to multiply by x plus 2 in the numerator. Okay, and what that tells me is that on my next step, my denominator is going to have a factor of x plus 5, another factor of x plus 2, and another factor of x plus 3. And then we'll just see what the numerator is. If I distribute the 5, I'll have 5 times x is 5x, 5 times 3 is 15. 3 times x is 3x, 3 times 2 is 6. Five x and 3x is 8x. 15 and 6 is 21. Which might be my answer. It will be my answer unless I can get something to factor and cancel. But nothing's going to factor out of 8x plus 21. And nothing cancels. So I'm done right here. Okay, so the moral of the story is right now we have basically two strategies in chapter 7. Cancel or common denominator. Now, that's going to change in chapter 7, section 4, because the nature of the problem is going to change. So let me show you a problem like we're going to work today. The directions now are not going to say simplify or perform the indicated operation. The directions now are going to say solve. And remember from discussions we've had previous in the class, you can't solve expressions. You can only solve equations. So we're going to have problems that have equal signs involved, like this one. 2 over x minus 3 minus 3 over x plus 3 is equal to 12 over x squared minus 9. Do you see that this is a different animal because it's not an expression, it's an equation. And our goal is going to be different. Our goal is to figure out what x is. So we're not going to be done on these problems until we write x equals something or we write no solution. One of the two. Okay, so what's the strategy for solving a rational equation? Our strategy is this, so I want you to actually put this on your paper. Our strategy is to clear the denominators. And by clear them, I mean try to get the denominators that are showing now to cancel. So why don't we go over to a little think box and see how we're going to do that. Okay, so let's go over here. Now this is not part of our notes. This is just us doing some thinking and some exploring. And let's create an equation like we had earlier in the semester. It's a little bit simpler than the ones we're looking at now. So let's say I had x over 3 plus a fifth is equal to 4. And we wanted to solve that. So let me ask you guys something. What would I need to get this 3 that's in the denominator to cancel? Wouldn't I need a 3 in the numerator? Okay. See if you agree to this next statement. I can do whatever I want to an equation, as long as if I do it to one side, how am I going to finish this? I also do it to the other? Okay, so the moral of the story is, if I want a 3 in this numerator, I can do it as long as if I do it here, I also do it here and over here, right? Now, why did I just do that? Because now these 3's will cancel. So I got rid of that 3 in the denominator by multiplying by it. How am I going to get rid of this 5? Don't make this hard, class. How did I get rid of the 3? After I multiplied by it. So how am I going to get rid of this 5? I'm going to multiply by it. That's right. I'm going to multiply by it here, but if I do it there, I got to do it everywhere. So I got to do it over here and back here. So those 5's cancel. Now, stop for a minute. And look at what just happened. Did I try to get common denominators? Shake your head, no. I wasn't trying to get the denominators the same because these were not expressions that I was just adding. I'm trying to solve an equation. What I'm trying to do is clear the denominators, and I did that by multiplying by each one until I got them all to cancel. And now over here I got 5x. In the middle, 1 times 3 is 3. And over here, 4 times 3 is 12, times 5 is 60. And I've got an equation that does not have any denominators other than 1. And we don't usually show denominator of 1. So by doing that, I created an equation that's a lot easier to deal with. So of course I could subtract 3 and then divide by 5. And here I'd get 57/5. Okay? All right. What we're going to do, now remember this isn't part of your notes. You don't need this. You don't need this. We're going to apply that concept over here on this problem. We're going to clear the denominators by multiplying by the denominators until they all cancel. Okay, class, so you think you got the notion? Now, what happens is on a test, students get confused between this kind of problem and an add an expression problem, and they try to get the denominators the same. So somehow we got to get into our heads that when it's an equal sign, we're not trying to get the denominators the same, we're trying to clear them. Okay, so how are we going to do that? Well, let's distribute this negative like we always do through the following numerator. If you get a minus, distribute that. And let's go through and factor any denominator that will factor. So class, will x minus 3 factor? Will x plus 3 factor? Will x squared minus 9 factor? Yeah, it'll factor x minus 3, x plus 3, won't it? Okay, now let's do what it says over here. Multiply by the denominators until you get them all to cancel. Is everybody ready? Aiden, are you ready?
Yeah.
Are you ready, Caitlin?
Yes.
Okay, so let's start with this x minus 3. So I'm going to multiply by it. If I multiply by it there, I got to multiply it in all these. Now, go through and cancel anything that'll cancel now. Well, these x minus 3s will cancel. And back here on the last one, those x minus 3s will cancel. So we got rid of some of our denominators. Okay, let's go to the next one then. Let's take this x plus 3 and let's multiply everything by it. So I got to do it to all of them. Got to do it here. Got to do it here. Got to do it back here. Now let's go through and cancel whatever will cancel now. Well, x plus 3 will cancel x plus 3. And in the back, x plus 3 will cancel x plus 3. And do you see that we have cleared the denominators now by multiplying by both of those? Okay, let's see what kind of equation we end up with. See if it's something we're familiar with. So now if I distribute the 2 times x is 2x. 2 times 3 is 6. Distribute the negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And on the right side, all I have is 12 because everything else canceled out. Now, is that an equation that you guys know how to solve? What we're left with there? And of course, the answer is yes. It's a linear equation. So I'm going to put the x's on one side and the constants on the other. So 2x minus 3x is negative x. 6 and 9 is 15. So negative x plus 15 is equal to 12. Okay, let's subtract the 15 from both sides. Cancel, cancel. So negative x is equal to negative 3. And divide negative 1, Logan says. Get those to cancel, and x is equal to positive 3. Now, on all of these, we are going to have to give a little bit of a check. And I'll talk to you about that after I know that everybody's caught up. So let me pause for a minute. So here's what the check is about. In our original problem, we had rational expressions, and those are like fractions, aren't they? And early in the semester, we said that there's one no-no with fractions, and that was you can't have 0 in the denominator. If you got 0 in the denominator of a fraction, it's undefined. So I have to make sure that my potential answer, in this case 3, doesn't create a situation where I'd have a 0 in any one of my fractions in the original problem. Any one of the denominators of the fractions, I should say. So we're going to substitute it back into the original denominators and see if we get a 0. Well, you can see in this first denominator, if I put 3 in for x, 3 minus 3 is 0, which would make that part of the equation undefined, which means 3 really isn't a solution. We have to throw it out. It was the only chance I had at a solution. So for this problem, there's no solution. There's no value of x that would make the left side equal to the right side. So that's the gist of what we're looking at in this section. So we're just going to practice some more. But that's the basic idea. So let's look at a few more here. So we did kind of a medium one first. Let's do a simpler one next. 2 over x minus 3 over 2 is equal to 7 over 2x. Now, before you get started, what are the directions on this problem? That's the strategy. What are the directions? What would the directions say?
Find the solution.
Solve. That's right. Find the solution. Solve. Okay? Because it's an equation. And don't forget to distribute this negative. It's easy to miss a sign somewhere if you don't do that. Okay, this time, none of the denominators are going to factor. They're all monomials. So let's go through and multiply by each one of them. So x here means I got to go x here and x back here. And then go through and cancel wherever you can. X's go here, and the x's go back here. Okay, still got a 2, so let's go through and multiply by that. 2, 2, and 2. And the 2's are going to cancel in the middle. And the 2's are going to cancel over here on the right. Okay, so we've been able to clear the fractions. Now, let's multiply. 2 times 2 is 4. Here in the middle, all we got is negative 3x. And on the right side, I got 7. Okay, stop. This is a linear equation, so we got our x's on the left, so let's put our constants on the right. So subtract 4 from both sides. Gets those to go. So we have negative 3x equal to 3. Hey class, what's x equal to?
-1.
-1. Well, it might be. We got to check it and see. So x equals -1, and we got to give it a check. Well, let's see if it works. Again, the only problem is if I end up with a 0 in the denominator. If I put it in for the denominator, in for x in the first denominator, that'd just make the denominator -1. That's okay. The second denominator is 2. That's okay. In the third denominator, 2 times -1 is -2. That's okay. So do we get to keep it? Yes, we do. X equals -1 is the solution to the rational equation. Hey, Mr. Black, let's do another one. That's a good idea, class. 2. Let's try blue, see how that shows up. 2. Ooh, that doesn't show up very well, does it, for you guys?
Try purple.
I don't have purple.
Oh, you don't have purple.
I'm going to try black.
Black definitely.
2 over 3x plus 1.
You haven't got that update yet.
I guess not. Equal to 1 over x minus 6x over 3x plus 1. Wonder why I picked this problem. Okay, you guys tell me what to do first.
Ooh-wee.
Okay. 3x plus 1?
There's something I need to do even before that.
Distribute the negative.
Distribute the negative, okay. Now what do you want me to do?
Now times everything enough for this one.
Yes, but really even before that I should see if any of the denominators factor.
Yeah. Ooh, one does.
Okay, which one does?
This -6 and the 3, wouldn't it be?
Now wait a minute. You didn't hear what I said.
Dang it.
I said, see if any of the denominators
Oh, denominator.
factor. And 3x plus 1 is not the difference of squares or the sum or difference of cubes. And x is a monomial.
Yeah.
So nothing factors. So you're right. The next thing we do is multiply everything by 3x plus 1. Okay, now go through and cancel whatever will cancel. So 3x plus 1 and 3x plus 1 in the first one, 3x plus 1 and 3x plus 1 in the last one. Okay, now, Caitlin and Aiden, what would you like for me to do next?
Multiply everything by x.
Good. Got to do it by all of them. X here, x there, and x back here. Okay, so it's not going to cancel in the first fraction. It will cancel in the second fraction. And it's not going to cancel in the third fraction. Okay, so let's see what we got now. In this first fraction, I've got 2x. In the second one, 1 times 3x plus 1 would just be 3x plus 1. And back here in the last one, negative 6x times x would be negative 6x squared. Class, do I have a quadratic or a linear equation?
Quadratic.
I have a quadratic on this one. So this is the one where we want to set it equal to 0. And then you're going to have a choice to make. We're either going to factor or use the quadratic formula. You guys want to put everything on the left or the right? I don't care.
Which is the easiest?
Whatever strikes your fancy.
Right.
You know, put it on the right. Okay. So if we're going to put it on the right, we'll subtract 2x from both sides. So I got a 0 on the left. Now do you remember that we want to write our polynomial in descending order? Okay, it's going to factor a lot easier if I do that. So I got negative 6x squared. 3x minus 2x is 1x, or plus x, and plus 1. Okay, Caitlin and Aiden, what's your preference? Do you want to use the quadratic formula or do you want to try to factor this?
Quadratic formula.
Okay, we'll use the quadratic formula then. That means we got to know the quadratic formula.
Yeah.
And my Tuesday, Thursday class didn't have a lot of luck remembering it the other day. Okay, so let me remind you, it's negative b, plus or minus the square root of b squared minus 4ac
All over.
all over 2a.
I remember.
Okay, ladies and gentlemen, so do you see that the a is negative 6? The b is this 1 right here that's on the x, and the c is also 1. So let's substitute in to our formula then. So x equals negative b would be negative 1 plus or minus the square root of, what's b squared? It'd be 1 squared, or 1, minus 4 times a is negative 6, and c is 1. All over 2a would be 2 times what? 2 times negative 6. Okay, does everybody understand where all that jazz comes from?
Yes, sir.
Okay. Well, let's do some simplifying over here. Negative 4 times negative 6 would be 24. Times 1 would be 24. So this part goes to plus 24. And 1 plus 24 would be 25. And the square root of 25 would be 5. So I got negative 1 plus or minus 5 over negative 12. Okay, so this represents two answers. Negative 1 plus 5 would be 4 over negative 12, which would make negative 1/3. Negative 1 minus 5 would make negative 6 over negative 12, which would make positive 1/2. Okay, and we have to check both of those.
Wait.
Now it may be that one of them works, it may be that both of them works, or it may be that neither one of them work. Could be any of those three things. So let's put them back into the original denominators and see if we get any zeros. Okay, so scrunch the problem back down. Let's try that negative 1/3 first. So class, let's go in right here. The question is 3 times negative 1/3 plus 1, does that equal 0? What's 3 times negative 1/3? So what? Let me ask you again. What's 3 times negative 1/3? Plus 1 is? 0, which means negative 1/3 goes bye-bye. It doesn't work. Let's put the 1/2 in. 3 times 1/2 plus 1. Well, look, 3 times 1/2, that'd be a positive number, plus another positive number. That's not going to be 0, is it? So that's okay. If I put 1/2 into the second denominator, For x, I just have a half, which is not 0. And 3x plus 1 is the same thing as I had on the first one. So 1/2 we get to keep, and the others have to go, the other one has to go bye-bye. Your assignment for Chapter 7, Section 4, where you're solving rational equations,
19 through 45 off.
is going to be page 392,
Okay.
19 through 45,
Oh, not 41.
odd.
You tell me not to mess up, you mess.
Hey, I didn't. You know what? I didn't.